Okay, so I'm looking at the questions for the week, 5/26. This is this week, and I got some couple good ones here. We're gonna do. I guess I was mistaken. Monday's not a furlough day. Tuesday is. So, hey, I'll see you on Monday. Anyhow, the first thing I guess I'm going to look at is the chapter problem, which I've got about 2 or 3 comments that said this doesn't make any sense. So I didn't put the rubric up there. My bad. I'm going to do that for sure. Get that up there today. I got a couple other things I want to do after this, so we'll work on that. I'll be happy to explain that and this to you and provide some clarification, hopefully. Let's just say this. Let's just say that here's what I need to do. I'm in the class, and I'm going to pick a conic section. All right. One of the things I recommended strongly is that you find some people to work with. All right, and I'll just give you a little background. Here's the deal. Okay, we've made the balloons, the hot air balloons, for the last 3 years or so, and I felt kind of like you got cheated on that a little bit. So I thought, I want to do something where you get to build something, and you get to work together and put some things to kind of a closure to the course, and I wanted to do that. So I kind of been thinking about this actually for a few years, and I thought this would be the time maybe to do this. So I would encourage you to find some people to work with. Obviously, you're going to have to communicate to them electronically, but you communicate people electronically all the time. So like I said before, that's not going to be an issue. But, so you work together, you get together, you go, hey, we need to pick a conic section. All right, so you can pick an ellipse, you can pick a hyperbola, you can pick a parabola. Okay. So, as far as, is there an easier one than the other? Probably not. If for you guys, parabolas are something that you've been dealing with for 2-3 years. So based on that would probably be the easiest. But as far as for this particular chapter problem, I don't see either one of them as being harder. Maybe the hyperbola would be the one that would be the harder to build a model, because you need 2 pieces of the reflective stuff. But I don't know if it really is that much harder, because I just kind of looked at it. But the parabola, so let's say you choose that. All right, you only do one. And you don't pick all 3 of them, you do one. So maybe what I would do is start off by drawing a graph. All right, so I'm going to draw a graph like this. And now I'm just going to put a parabola on there. Now, it doesn't say where your conic section has to be, all right, on this X and Y axis. You can put it any place you want, all right? All these conics have either a center, right, or a vertex. In the parabola case, it's a vertex. Put it any way you want. And, I guess I've always been kind of a believer in the KISS principle, where you're just going to keep it simple, right? There's another one, but I'm not going to say that one. So keep it simple, right? And just so when you're doing some of this chapter problem, that's something you want to follow by. All right. So let's keep it simple. Let's put the vertex at 0, 0, right? So now I'm going to draw a parabola. How about that? There it is. There's my parabola. Done. My vertex is at 0, 0 right there. Mine's kind of not drawn, but I know what I want it to be. And so now what I need to do is figure out, where should I put the focus? All right? Where should I put the focus? Is there a place where I need to put the focus? No. You can put the focus any place you want. All right? It doesn't make any difference. So maybe I'll put the focus 1, 2, 3, 4. All right? And I'm just randomly choosing 4. All right? So there's my focus point. Okay? So once I have that, I know where my directrix is. So on the chapter problem, right, you have those things. And what I'm doing right now, hang on for just a second, is I'm going down here to find the darn thing, and I just screwed everything up because I clicked the wrong doggone thing. Okay, so let me go down here and find it. Maybe is it up here? Oh, there it is. It's in the wrong spot. Two people have already turned theirs in. I don't know how they did that. All right. So, here we got it. Send me a picture of your model. Okay? Make a graph of your conic. So, that I'm doing this right now. I'm making a graph of it. I'm showing the vertices, the focus, foci, and directrix. Okay? So, I got to show the directrix. Well, we talked about the directrix yesterday, but don't do this one. Okay? So, don't turn it in and say, I'm going to do the one Patterson did. That doesn't help me. All right, I'm giving you an example here of what you want to do. So, okay, my directrix then is going to be right here, 4. There it is. So there's my graph, right? There's my graph. Write an equation. You should be able to write an equation from that. All right? You should be able to do that. Can I rotate the other way? If you want to, but again, I don't know why. It makes it a little harder, but if that's what you want to do, go ahead. All right? Find the vertices, foci, and directrix. Got it. You'll need to plot the focus on your axis. Got it. Place the light source at the focus. Now, here's what we need to do. We got all this stuff. I mean, they took care of about half the problem already. So here's what I'm going to do. Now, I got to go get some stuff. Okay? So either I do or my partner, somebody, is going to go get some sort of reflective material. All right? You can do that by going down to ACE, like I suggested. All right? They have some flashing, it's called. It's called flashing material. And if you go there and you ask, it comes in sheets. I'm trying to think of what it looked like when I was down there the other day. It might have looked like this. And I have little rough edges here. And I have something here. And what happens on flashing is it's made for heat. Okay? So you can connect these two edges together. So the purple and the red would come together. They slide down, all right, and then you could get another piece. So these two will come together. All right, so, somebody will show you. I mean, and you can see, you guys are smart enough to figure it out. You'll see where they kind of slide together. So you can make it as long as you want. All right, so if you want your parabola or your ellipse or your hyperbola would be perfect because then you can buy 2 of these things and be done. Okay, once you put those things together, you can form it to make your conic section. And what happens is that this stuff here that I'm going to look at right here, this is reflective. So if I point a laser light at it, it's going to bounce off. Right? The laser light is going to come in here and it's going to bounce off. All right. So what I'm going to do now then is once I have my flashing is I'm going to go back to my graph. Go back to my graph and I'm going to put my flashing right on this. So maybe what I've done is I have made, like I did, I put a piece of cardboard down. Okay, so here's my cardboard right here. All right, I drew some axes on there, and I drew my directrix. And now I'm going to put my flashing right down on that. So this is my cardboard. Okay, and again, you don't have to, you can make it any size that you want. Okay, but there is a stipulation. When you put your little laser pointer right here, okay, and you point it, you've got to make sure that you got enough room to move it around. Okay, it will move around. Now let's go back to this. Okay, I'm going to change my color here back to red. All right, so there's my parabola. I got my X and Y axis drawn. I got my focus there. I got my directrix there. I got it on a sheet of paper. What I did was I put just some little tiny finishing nails here and here, and you can put some there if you want. And that just gives me the form of that. In fact, if it was me, I probably would have traced the parabola on there, and then I could put the little flashing material so that it sits there on top of that tracing curve. And now, so it's up high, right? Because I can't show this three-dimensionally, but you can look at the picture. And now you have your flashing with the reflective material on the inside. There's your focus. And you got like some sort of a little laser pointer. And again, I found those at Ace. They're like $2. Okay, $2. Just don't bring them to school next year. All right. Then you've got that built. You got your cool thing here, model. You're looking at it going, it's kind of neat. All right. Then you got your focus point. So now what you're gonna do is take your laser, all right, and you're gonna point it. Let me go back to this. You're gonna point it at the model. So the laser light's going to come in, and it's going to hit that parabola, and it's going to bounce off. Oh, well, now I'm going to rotate it over this way. And the laser light's going to come in, and it's going to bounce off. And then you're going to rotate this way, and the laser light's going to... And you're going to get all these different reflections off of that parabola, okay? And it's going to go somewhere. So that's what I'm interested in. I want you to be able to trace those paths of the laser light and tell me, say, this is what it did. All right? This is what it did. Okay, so once you have your light source and you point the light source at the conic, and then you rotate that light source around a few times, all right, you should notice the path of your light source as it reflects off the conic. You'll see it. It's going to show. All right? Because if this is highly reflective material, it's going to bounce off. It works well on the flashing. Anything, basically, that is aluminum or shiny is going to reflect. Okay, I've seen it done with aluminum foil. But the problem with aluminum foil is you really got to get it smooth. If you have just a little bit of a crack or like a little bit of a fold or a crease or something, it probably isn't going to work very well. So you don't have any wrinkles. How about that? You just want to keep it as flat as you can. You could take some cardboard, okay, and get your cardboard, make sure it can bend, right? And bend it along there like tag board. Poster board would probably work pretty well. If you went to the Dollar Tree, got some poster board, you could cut that and make that work, and then you could put the aluminum foil. You could either probably tape it on there, maybe. You don't need it. You're only going to point it at the light source at a certain point right there on the aluminum foil or on the flashing. It's not going to be all over the place. So if you put a little tape here and a little tape, you're going to be okay. It shouldn't hit that. So you probably want to make that, if you use some poster board, maybe 6 inches, I'd say, high. That'd probably work. That way you got a little room on the bottom and top. So you got your foil on there. That'll work. Should work. Point your laser, bounces off, and you'll see the trace. So then you're going to rotate it. Let's see. I'll provide a detailed description of the reflective property of conic. So just tell me, hey, where's the reflections going? And on the ellipse, it's interesting. It really is where those reflected lights are. Now, let's say you didn't know. You go, shoot, Barrett, I have no idea. Then you do some research, find out, well, where should it go? And then go back and see if that's really what's happening. Because you might not know where it's going to go, right? But you're researching, figure it out. Okay, this is a good problem for you to do. On your graph, draw 5 of the light source paths. So then, let's see. I got 1, I got 2, I got 3, I got 4. So I got 5 of them right there. All right. So I'm just drawing them in, showing them where they go. All right. And then research in real life situation where your conic and its reflected property is used. Just look it up. See where does this thing use at? Where is a parabola used at? Okay, and its reflective properties. I know they make nice arches, and you see them at McDonald's, and the arches St. Louis has it, and all. But that's not a reflective property. I'm interested in the reflective property. And again, once you look at that up, I bet it's going to hit you. You're going, oh yeah, that makes sense. Okay. So that's basically all I'm looking for, all right? And again, I'm encouraging you to work together because somebody, obviously you can't go over to so-and-so's house and build them out. Well, or maybe your parents will let you, I don't know, all right? But I'm not going to say for you to do that and then get in trouble. So, that's up to you guys, right? That's not up to me. But somebody definitely is going to be building it, and then work together to figure out what's going on. And you could have somebody video in it while you're moving the flash around, and then share that video with your group members and say, "Hey, look, this is what we found out." Okay, this is like I said, it's a good problem for you. After Monday, you're gonna have a quiz, and that's it. The rest of the time, you work on the model thing. All right. So, and Monday's information is going to be short because we're about done with parabolas, and there isn't a whole heck of a lot more to say. I'm just going to say a couple more things about them, and that's going to be it. So, I don't know if that helps. I don't know, what you just said you wanted me to explain it, so I kind of did, but I'm not sure that was a good enough explanation. So, my guess would, if you want to ask more questions, ask more questions about it, and I can do that, answer those for you, be happy to answer them for you. I want it to be something that is not, that is rather fun to do. When I built the model out, it didn't take me very long. All right, it just didn't, either one of them, it just didn't take me very long to do it. All right, so once you get that built and you play around with the light source, with the laser, you're not going to have, it's not going to take you that long. All right, and like I said, you can research things and look things up. And getting into the equations and stuff, you should be pretty good at that. All right, that is what I have for that part. All right, what about some of the other questions that we have? Let's see. Somebody wanted to see something like page 46 on 653, so I've made up one of those guys. And here, what we want to do is figure out what kind of conic this is. And we want to find vertices, we want to find foci points, we want to sketch it, we want to find a directrix, if that is applicable or not. There's applicable, excuse me. We're just going to run through the whole gamut of things, sorry, that we need to do. Okay, and this is a good question, because when I give you the quiz, there's going to be 3 questions, right? And I can tell you right now, one of each conic. And I'm going to say, tell me what it is, find the foci, find the vertices, give me the directrix, all that stuff. All right, that's what I'm going to ask for. And it might be in this form. So you might have to change it into a form that you can deal with. All right, so you should be able to do that. So let's go with this. All right, and let's see. What I said was we want to take and put the x's kind of together. So I'm going to go like this and put that 100 there. I'm going to have the 9y squared here and the 54y there, so that the x's and the y's are kind of together. That's what I want. Okay, now I got to complete the square, right? We talked about this. You got to complete the square on this thing in order to get it to work. So I'm going to divide by 25 because that's the number in front of that x squared. All right, and I want to get rid of that so that I can complete. Otherwise, I can't do it. I got to have an x squared there, so I'm just going to divide everything by 25. So now I have x squared. I have 4x. All right. Do I worry about this? No, because I know that I am going to multiply by 25 at some point, and there's no reason for me to divide those ones and then multiply it and get back to where it was. So I'm just going to leave it alone. So now I get to complete the square on this. So that's what I'm going to do. So I'm going to go x squared plus 4x. Remember, the whole idea is I'm going to take half of that 4, that's 2, and I'm going to square it. So I'm going to square it and add it, but I got to do the same thing over here. You can't just add something to one part of the equation and not put it to the other part of the equal sign. Okay, here we go. So now I'm going to get x plus 2 squared, all right, plus, and then I got all this stuff that I haven't done a thing with and don't plan on doing anything with. All right, and that's plus a 4 there. Okay, so now I'm ready. It's time for me to multiply by 25. All right, Alright, so I'm going to multiply everything by 25. So I'm going to get 25 on the outside of this, and that's what I want. Right. This stuff, nothing much happens there. Let me get rid of these stragglers. Always got the stragglers. Equals 44. But then I got to take 25 times that. So now I have 100 over on that side. Okay. So that's good. So now I'm going to do the exact same thing with the y's. So I'm going to divide everything by 9. All right, so I'm going to have 25x plus 2. Remember, this is done. All right, so I definitely don't want to mess around with it. I'm going to leave that alone. Y squared minus 6y equals 144. Just added those. Divided by 9. Okay, so there it is. Now I have that. So I'm ready to complete the square on the y's. So I'm going to do that. Y squared minus 6y. I'm going to take half of 6, that's 3. I'm going to square that. Put that on the other side. So that's going to go right there. Okay, that stuff, this stuff, not going to do anything. It's just going to, I'm not going to divide by 9, okay, because I know what's coming up. There we go. So now I'm ready. I'm going to rewrite this as y minus 3 squared, okay. Let's multiply everything by that 9. Oops. So, now I'm going to multiply by 9. So again, I'm right back to this. That's where I was when I started on this problem. I got the 25 here. Okay. I got the x plus 2 squared. There we go. I don't know why it's doing this. There we go. Plus y minus 3. So I got a 9 out in front of that. Like so. Okay. 144, but I got 9 times 9, which is 81. So I'm going to add that. It looks like that. I hope this works out. Oh, yeah, it's going to. Okay. I was worried for a second. All right. So, what do we got? Well, we got that mess, but this here is 225. Now, it needs to be a 1 because all my conic sections, ellipses and hyperbolas have a 1 there. So let's divide that whole thing by 225. So I get the 1 that I want. Now here I have a 9 and a 225. Right, that's going to reduce down to y minus 3 squared over. So remember, I'm dividing by 225. So basically I have 9 over 225, which is 25, plus x plus 2 squared with a 9 on the bottom. So there it is. All right, so now, like I said, on your quiz, then you should be able to tell me what this is, all right, what the foci, vertices, the whole gamut of things. Well, this is an ellipse. How do I know it's an ellipse? I know it's an ellipse because this thing, all right? If it's a hyperbola, I got a minus there. But I don't, I have a plus there. How do I know it's not a parabola? Well, because in a parabola, only one of these guys is squared, and both of them are squared. So I know it's not a parabola. It doesn't even look anything like a parabola. So I know what it is. It's an ellipse. Okay, thanks. It's an ellipse. All right. So that means I got to find some vertices, and I got to sketch it, and I got to find foci, and the whole bit. So what I'm going to do, I'm going to draw it because I like to see things. All right. I got to see it to believe it. So I'm going to see this. All right, here we go. Let's do it. We're going to do this. All right. So x plus 2. So that means I'm going to go back 2, up 3. There's my center point. Oh, that's one of the things I needed to say. Negative 2, 3. Got the center done. Okay, that was one of the things that I needed, and now I got it. Okay, now I need a vertex. Well, in the x direction, I have 3. So that means I'm going to go over 3. So I'm going to put a point there. 1, 2, 3. Going to put a point there. There's one vertex. So let's see, that would be 1, 3. The other one, I'm at -2. I'm going back 3. So that's a -5, 3. Got that one. That looks like a, I don't know what this looks like, but it doesn't look like a -5, does it? -5, comma 3. Vertice, there's that. In the y direction, I'm going to go 5. So let's see, I'm 3, 4, 5. So that'd be there, and way up here. And now I can sketch this thing, so it looks like that. And now I got to come up with my other vertices. Well, my other vertices are going to be -2, comma. So now I got to go 5 from that 3, so that gives me 8. I'm going to go -2. From this 5, or from this 3, I'm going to go down 5. That gives me -2. And there's my vertices. Right, got it. So what did I do? I went to the center point. I went up 5, down 5. Okay, down 5, up 5. Focus point. Well, with the ellipse, I just got to remember that it's a squared minus b squared equals c squared. So here we go. A squared is 25. B squared is 9. This is going to be 16. All right? Yeah. Oh, hey, that works out pretty nice. That means it's 4. So I need to just go 4 in the direction of y's because 25, that's higher. So I'm going to go 4 up and 4 down. 4 up, 4 down. Okay, so let's write those focus points. Focus. So if I'm 4 up from the 3, right, then I know that I am at 7. So that's -2, 7. If I'm 4 down from the 3, that puts me at -1. And there's my focus point. Okay, there's my focus points. So now I got everything. I told you it was an ellipse. I wrote it in this form. I was able to find the center, the vertices, the foci, and sketched it. All right, there you go. So that is what that one looks like. That particular problem is asked for eccentricity. Eccentricity is a C over A. So you can just easily say, okay, eccentricity is equal to C over A. My C value is 4. My A value is 5. There's my eccentricity. All right, but, you know, finding eccentricity and figuring out what the heck it is and what it means is probably more important. So I did one of those. Let's see. The other question was, what's a directrix and how do you find it? So the directrix is the other side of the parabola, so to speak. So let's go ahead and make some axes here. All right. And let's draw a parabola. I want to draw one like this. Maybe. I'm trying to get it to draw, but see, it's not yet. There we go. Okay, I want to put this at 1. All right, so there is my parabola. And since it is facing this direction, I'm going to go x equals, and let's just go with a 1/4 y squared. Now, my vertex, and I didn't draw this very good, guys. There, that's better. My vertex is right there, okay, at 1, 0. So that means that my y part is 0, so I don't have to worry about that. And the x part is at 1. So I'm just going to put a +1 there at the end. So I have 1, 0 as my vertex. All right, so I got that. Directrix. Well, at the focus point, now we got to find that. So the focus, okay, remember, has something to do with that number. So 1/4 equals 1/4 C. Okay, where C is the distance from the vertex to the focus. Well, C is obviously 1. So that means that my focus point must be right here. Okay, so it's 1 unit away. And so let's see, that's going to be 2, 0. There it is. And the directrix then is going to be 1 back. So the directrix is going to be right there. So the directrix is x equals 0. Right on the y-axis. Okay, so there's my directrix. And then I guess it's just a line. That's basically what it is. Okay. The main thing on the parabolas that we talked about was that for any point on the parabola, the distance from that point to the directrix is the same as the point to the focus. So it's PF equals PD. That was the big thing there. So hopefully that explains everything for you. I guess if you have more questions, you can ask. Again, Monday, I'm not going to do a whole heck of a lot with parabolas. I think the Wednesday, I got your quiz there. I kind of already told you what that's going to look like. You can start working on your chapter problem. Work on that. You can start working on it right now. There's nothing that that I'm going to give you on Monday. It's going to give you some insight on doing that. So if you do the ellipse, then same thing. Right, draw it out. Draw it out first. All right, I think I'll make an ellipse that looks like this. All right, here's my vertices. Here's my vertices. Here's my vertices. Put some numbers on there. You can use any scale. It doesn't have to be super huge. Mine was pretty big, but you got to be able to find that focus, and you got to be able to put that laser pointer there and spin it around, right? And if you make it too small, it won't spin around there. So we got to look at that, see where that's going. Okay, shine it here. Where's it going? All right, and look, and it hopefully if you do enough with the laser pointer, you point it and you put it at both foci and you move it around a little bit. You're gonna follow that path, that lighted path, and you'll see it. It'll show. Okay, and if you need more, let me know. Other than that, have a nice weekend, and talk to you Monday.